In this presentation, we will continue to learn the importance of electronic configuration. So in this first opening slide, you see an image of a periodic table where the elements are arranged in an order of increasing atomic number. So whenever we talk about a periodic table, here we have a skeleton, just an outline of a periodic table without the elements written so that you can have a better idea. So whenever we talk about a periodic table, we will use two terms. One is the period, the other one is the group. So what are periods? The horizontal rows in the periodic table are called as period. So each row is called a period and the elements in each row or each period will have the same number of shells. So the first row where we have the two red boxes which are nothing but hydrogen and helium are the elements in the first period which will have only one shell. So the period will tell you the number of shells the elements will have. So now the second row, which is called as a second period, here it is represented by orange boxes. All these elements will have two shells. So they occupy the second row, which is also called as a second period. Similarly, you tell me the green boxes. So it is in the fourth row, right? Am I right? So it is in the fourth period, which means all these elements will have four shells. So which are nothing but four orbits, or it is also called as four energy levels. So what is the next term? It is the group. So the vertical columns. So horizontal rows are called periods, whereas vertical columns are called as groups, or it is also called as families. So the elements in that particular group or in the particular column will have similar properties, and that is why we call them as the same family members. So suppose you consider this yellow column. We call it as third column. So this is the first column in a periodic table, second column. So these columns you will learn in detail. They are of more complex electronic configuration. Just we will move to the third column, which is the yellow color box. So those elements in that particular column is called a family, because they all have similar number of valence electrons. All these elements will have the same number of valence electrons. So they will have similar properties like so on, like green boxes, all in the same family. So they will all exhibit the same properties. So what are the two terms which you have to be thorough? Horizontal rows are called periods. So we have totally 1, 2, 3, 4, 5, 6, 7 rows. So these rows are continuation of these two last rows. So we have totally 7 rows, and then we have 18 columns in a periodic table, right? So now let us consider carbon atom whose atomic number is 6. So it has two electrons in the first shell, that is first energy level K shell, and 4 electrons in the second energy level, which is the L shell. So L shell is the outermost shell, the valence shell, and we have 4 electrons which are the valence electrons of carbon. Since they have two shells, they are in the second row. Now just see the position of carbon in the periodic table. It is in the second row along with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So all these elements will have only two shells. So carbon has two shells as you see here. And see the number of valence electrons. It has 4 valence electrons, and that is why it is placed in the fourth column along with the other elements in the same family called as carbon family, which are nothing but silicon, germanium, tin, lead. Si is silicon, G is germanium, Sn is tin and Pb is lead. You will learn about these symbols in detail in the next lesson. So these elements in the carbon family will have the same 4 valence electrons, and they will exhibit similar properties, and that is why they are placed in the fourth column, since they have the same valence electron as you see here. Now we will consider one element. I will tell you phosphorus. Now tell me in which row it is in? Yes, it is in the third row. So how many shells phosphorus will have? It will have 3 shells, and it is in the fifth column. You can see the representation of the column number on the top, which is given here with a Roman number 5A. So now I told you these are the other columns which you will learn in detail in the higher classes. So after the second column, you have to shift to this third column, fourth column, fifth column. So phosphorus is in the fifth column, which means it will have 5 valence electrons. So phosphorus is in the second row, that is, third row, which is the third period, which will have 3 shells, and it is in the fifth column, that is in the fifth family along with nitrogen. So it is called a nitrogen family. Phosphorus belongs to nitrogen family, which will have 5 valence electrons. Now you just see the first column, which is the most highly reactive metals. So they are all metals which are highly reactive, except the top box, which is hydrogen. All other are the same family, which is called as alkali metal family. So they all have only one valence electrons, and that is why they will all exhibit the same similar properties. They can be easily cut with a knife. They are lithium, sodium, potassium, rubidium, cesium and francium, which are the alkali metals in the first column. So now you see the valence electron in the first column. All the elements in the same column have same valence electron, and the second column all the elements have 2 valence electron. In the third column they all have 3 valence electron, and so on. And in the last column you see, the last column is the noble gas column. So we have helium, neon, argon, krypton, xenon and radon. All these have complete outermost shell. So they are inert in nature. They will not react with any of the other elements. We will deal this in the next class in detail. Now you see one of the alkali metals, sodium, which is generally stored in a mineral oil. It will not be just kept outside, as it is highly reactive because it has just one valence electron. All the alkali metals are very highly reactive because of just one valence electron which is present in the atom, and it can be easily cut with a knife like butter. So you know that metals are usually hard, for example iron, and then copper, lead and so on, whereas sodium is a very soft metal. You can easily cut with a knife, and it is highly reactive. It reacts vigorously with water. When it reacts with water, it gives out a lot of heat and light, producing sodium hydroxide. So here you see the reaction of sodium with water, where you have the exothermic reaction, which is that you are seeing here with a lot of heat and light. So it is important to understand the position of the elements in the periodic table, which is based on their electronic configuration, as I told you earlier. So these elements in the last column, which is called as inert gases, they don't react with any other elements or any other atoms because of their complete valence shell. All these have the complete shell, the last shell with 8 electrons, so they will not react with other atoms to form molecules. So they are called monoatomic elements. We will learn in detail in the next coming classes. So helium has only one shell, which is complete with 2. So all these are inert gases, since they have the complete outermost shell. So it is important to understand the valence electrons, because the chemical behavior of an atom depends on the number of electrons in the last outermost shell, which is called as valence shell. So now hope you have a clear idea. So we will discuss in detail in the next coming classes. Thank you.